Okay, we're in the home stretch. This is the final video about the area of non-right triangles. I'm going to go ahead and label this triangle over here A, B, C. Those are the angles, and that means that my sides are A, B, and C. Okay? If we are given the length of two sides of a triangle, in this case it would need to be A and B, and the angle between them, that's called the included angle, angle C. So we have side, angle, side. The area of the triangle is 1/2 the product of our two sides, AB, times the sine of the included angle. And from a previous video, we saw that depending on which two sides we had and which angle we had, there are three different formulas for the area of a triangle. And since the area is the same on one triangle, no matter what two sides and what angle you're given, these formulas all equal each other. So I'm going to rewrite these all equal to each other. I'm going to just multiply each one of these by 2. Why did I do that? Because I wanted to get rid of the 1/2. Okay, and I'm left with BC sine of A equals AC sine of B equals AB sine of C. Oh look, there's a C in 2 of these. Let's divide by the side C to get rid of C. I can't get rid of it in the last one because I don't have side C to cancel out. I'm going to try dividing everything by B now so I can cancel out the B over here. I want to get sine of A by itself. So I'm going to divide by B. There's no side B to cancel out over here. Over here I can cancel out a B. I'm going to rewrite this so that it's a little bit neater. Sine of A, so far I have sine of A equals side A sine of B divided by side B, which equals A sine of C divided by side C. I still have the A's that I can get rid of here. If I divide all of these by A, side A, these cancel out. And I can't simplify anymore. I'm left with sine of A divided by A is equal to the sine of B divided by side B. And that's equal to the sine of angle C divided by side C. This is known as the law of sines. Okay, so the law of sines. Sine A over A equals sine B over B equals sine C over C. That's the formula for the law of sines. What do I do with it? Well, here is a side, here's an angle. Same thing here and here. I can use the sine rule to solve problems that where I have triangles, non-right triangles, where I'm given either two angles and a side, so angle, angle, side, or two sides and a non-included angle, so side, side, angle. What can I find? I can find side, or I can find an angle measure. So the law of sines is used to find side lengths or angle measures. Let me show you how it works. Let me show you how this works. So I'm going to label this triangle A, get my pencil back, I'm going to. Okay, let me show you how it works. Here I have a triangle. I'm going to go ahead and label the angles A, angle B, angle C. Across from angle A is side A. Across from angle B is side B. And across from angle C is side C. I'm also given two angles and a side. So here I have an angle, angle. Here I have another angle, and then I have a side over here. What's important here is that I have one of my ratios. So if you look, I'm going to go ahead and write the sine of B over side B equals the sine of C over side C. The reason I chose those two is because I have angle B and I have side B. I have one complete ratio. That's why I need angle, angle, side, or side, side, angle. I have to have one complete ratio here in order for the formula to work. I'm looking for side C, so I need to use angle C to find side C. Now I'm going to go ahead and fill in the values I have. Sine of 37 degrees equals, divided by 23 centimeters equals the sine of 48 degrees, right? Because that's angle C over C, which in our case C is x, and that's what we're solving for. Here I have a complete ratio. I have a ratio and then I have another ratio, and they're equal to each other. And if you remember from geometry, when you have a ratio, you can cross multiply. Okay, so x times the sine of 37 degrees equals 23 centimeters times the sine of 48 degrees. And now I want to isolate x, so then I'm going to divide by the sine of 37 degrees. Well, I have to divide this side by the sine of 37 degrees as well. You should do this all in one step in your calculator so you don't get a rounding error. So because you're doing this in one step in your calculator, you need to protect the top part of your fraction by putting parentheses around it. When I do that, I end up with x is about 28.4 centimeters. And you know, I can go back and look at that. If x is 28.4, does that make sense? 37 degrees, the side across from 37 degrees is 23 centimeters. 48 degrees is larger than 37. That means this side should be larger than this one, and it is. So my answer actually makes sense. Here's one for you to try. Pause the video, work it out, restart the video, and check your answers. Okay, if you got 13.4 centimeters, you did good. How did you set it up? You should have done the sine of 48 over 11, because that's the ratio I have, equals the sine of 115 over x, because x is the side I'm looking for. Cross multiply, x sine of 48 equals 11 sine of 115, and then divided both sides by the sine of 48 to get x equals 11 sine of 115, and don't forget the parentheses in your calculator, divided by the sine of 48. Why don't you just give it one more shot just to make sure you're good? Pause the video, work through the example, and then restart and check your answer. Here's the worked out solution. Hope you got 21.3 centimeters. Thanks for watching, and I'll see you in class.